In this video, I want to look at particular applications of circular functions. Circular functions give you what we call a sinusoidal, that's how you say it, sinusoidal function, which is this wave-like function that looks like this. And any kind of circular motion, and when I mean circular motion, I'm talking about things spinning in a circle. Any type of circular motion, when you track its height or its displacement from a particular point over time, gives you this sinusoidal graph. And so when you're making models of circular functions and you're working with circular motion, it's really important that you know what's on the vertical axis of your graph and what's on the horizontal axis of your graph. One of the most common models that they work with is a Ferris wheel. So we're actually going to have a look at that. So here is our Ferris wheel spinning away. You can see that one of the carriages has been coloured in blue, and that's the one that we're going to focus on. So if I get rid of all of the other carriages, there's the blue carriage up there. And what we're going to be measuring this time around with the Ferris wheel, because there's different things that you can measure. Along the horizontal axis, we're going to measure time, and along the vertical axis, we're going to measure the height of the carriage above the ground. So I'm going to turn the graph on, and what it's going to do is, there's our function, and there's the equivalent point for our carriage. And if I connect the two, you can see that it's actually measuring the height of the carriage above the ground as time goes past. So although our graph comes down to 0, you can see our curve comes down to 0 here. Normally with a carriage, it's some meters off the ground. There's some kind of platform here. So whatever they tell you that the height is of the carriage, you don't need to worry about whether the height of the carriage is measured to the floor of the carriage when you get in and stand, to the roof of the carriage, to the middle of the carriage. That doesn't matter. All you need to use is whatever measurement they tell you and just refer to it as the height of the carriage. So that's how a circular motion that's going around and around and around here is generating our sinusoidal curve. So there's a couple of things that are important to relate between the actual circle itself and the shape of the curve. So we talk about the amplitude of the curve. Sorry, let me just go on here. So this is the amplitude of the curve here, and the equivalent is this distance here on the Ferris wheel. And if we talk about the height of the Ferris wheel, or the diameter of the Ferris wheel, then we're talking about this distance here, which is the range for that particular function. If we're talking about the period of the function, okay, so the period of our function here, this is the time that it takes for one rotation. Okay, this bit at the top is the highest point that the carriage gets to. This is the lowest point the carriage reaches. And so you need to be able to take the period, the amplitude, the range, all of those things, and make sense of them in terms of what's happening with the Ferris wheel. In this diagram here, it says you're sitting on a Ferris wheel at the 3 o'clock position. So this is the position over here, and you're in this point here. The radius of the Ferris wheel is 18 feet. Don't worry about the units, it's 18, which means that by the time it turns to the top, you're going to be 18 above the median level, which means that this is 18 to the highest point and 18 to the lowest point that it's at as well. And it says, and the lowest point of the wheel is 6 feet off the ground. You can see that there's a little gap there, and there's our 6 feet off the ground over here. And then it says, write a set of parametric equations, and that just means that an equation with a parameter in it, and in this case our parameter is going to be time, to represent the position of your seat with respect to time, assuming that the Ferris wheel makes one revolution every 40 seconds. And so 40 seconds on our time axis, this will be one period of our graph. And so what I'm going to do is I'm going to make this run. Just ignore for the minute, just ignore the graph on the left hand side. So press start and you can see it turning, and you can see that as this goes up, we're generating the same kind of height graph over here. And it's going to give us the same shape curve as what we've looked at before. And if I turn on the parametric equation, that's the equation for the height. Okay, so this is the equation for the height above the ground, our y value. Okay, now what on earth is going on over here? We're also generating some kind of sinusoidal curve. What's happening here? This is a parametric equation for x. So what this is looking at, if I just reset it, pause, hang on, reset. What this one is looking at is the position of u relative to the x-axis that's running here. So if you imagined that to generate your height graph, you're using a y-axis here, and you're looking at where are you comparison to your y-axis. This one looks at how far are you from x is equal to 0. This is the 0 mark here. So when you start, you're actually 18 to the right, and we're going to determine that as being right by calling it a positive number. So this is going to be positive 18, which means that over here, this is going to be negative 18 for our x value. And we're going to look at how that x coordinate of that graph, that point changes as it rotates. Okay, so let me turn this on. And let's have a look. So you can see that it started at 18, and as it's moving around, it's getting closer to being above that 0. And then it's to the left-hand side of that 0 until it comes down to minus 18. And then it comes back in. So you can measure more than just the height of the carriage on a Ferris wheel. You can, in fact, measure its distance to the left or to the right of the center point of the Ferris wheel. And its equation for x is also a sinusoidal curve, and that is it right here. So that's why I was saying at the very, very start, it's really important for modelling questions that you are super vigilant with checking what am I measuring on my vertical axis here. Okay, so on the vertical axis for the graph over here, what we're actually measuring is we're measuring the distance, if you like, from the center of the platform that it starts at. So this is the center of there's a little platform that you get onto to get onto the Ferris wheel, the center of the platform. Whereas the other graph over here is measuring the height of the carriage above the ground. So when you're doing application questions, be really, really cautious in checking what it is that's actually going on the vertical axis and what's going on the time axis, or what's going on the horizontal axis as well. Because in both cases here, our horizontal axis is time. It could just as well be measured against the angle that we're measuring that the Ferris wheel has turned as well. And you'll get exactly the same sort of graph for those. So make sure you're checking your axes very, very carefully, making sure that you have the right measurement on there.